Welcome to our introduction of Friedland's XYZ insurer example used in Chapters 6 through 13 and 15. First, we'll begin with some Chapter 6 comments. Chapter 6 introduces the XYZ data and discusses some diagnostic tests that can be performed. Friedland explains how these tests may help the actuary determine the most appropriate method to estimate unpaid claims. We'll return to these diagnostics after demonstrating the different methods available in Chapters 7 through 13. Estimating unpaid claims, a terminology reminder. Friedland discusses terminology surrounding the words reserving or estimating unpaid claims and prefers the latter to be consistent with ASOP 43. Similarly, unpaid claim estimates is used instead of reserves when discussing the estimation methods, and carried reserve is the amount the company selects and reports in its published financial statements. An unpaid claim estimate can be broken down into 5 components. 1. Case outstanding, which are claim department estimates of future dollar amounts they believe will be required to settle or close existing claims, that being claims that are known and reported. There are 4 other components that are often grouped together under the broad definition of IBNR. The provision for claims incurred but not reported, which is pure IBNR. The provision for future development unknown claims. The reopened claims reserve. And the provision for claims in transit, incurred and reported but not yet recorded. Note that Friedland generally uses the broad definition of IBNR, including pure IBNR, and IBNR, where IBNR is incurred but not enough reported, which are amounts 3, 4, and 5 listed above. Some useful relationships include estimated ultimate claims, which are paid claims plus estimated unpaid claims, total unpaid claims, which is the total reserve, which is case outstanding plus IBNR. Estimated ultimate claims can also be equal to reported claims and IBNR, broadly defined. Unreported claims, or IBNR, can be determined as total unpaid claims minus case outstanding. And finally, reported claims are paid claims plus case outstanding. Friedland notes that actuaries often use case incurred losses to describe reported claims. An introduction to aggregate and structural reserving. Before we begin, aggregate reserving and structural reserving are terms not used by Friedland. We use them here to help you differentiate the types of reserving methods discussed in the Friedland text. Aggregate reserving methods are techniques that project the ultimate value of a group of claims without using information with regard to the actual claim process. In practice, most reserve estimation work is done using aggregate methods. Other distinguishing characteristics of aggregate reserving methods is the use of cumulative rather than incremental data, and it usually requires the estimation of claim development factors, CDFs, except when using the expected claims method. They generally do not use claim count information, and it's common to use reported losses rather than paid. Note, Friedland demonstrates methods using both the reported and paid data. Here we're going to focus on reported data. Again, 4 chapters covering aggregate reserving methods in Friedland are Chapter 7, Development Techniques, Chapter 8, the Expected Claim Technique, Chapter 9, the Bornhueter-Ferguson Technique, and Chapter 10, the Cape Cod Technique. Structural reserving methods, used in Friedland Chapter 11 through 13. Structural reserving methods use a particular aspect of the insurance process to project ultimate claims. These methods are generally more complex, and structural methods usually require more data, such as claim counts. 3 chapters covering structural reserving methods include Chapter 11, the Frequency Severity Techniques, Chapter 12, Case Outstanding Development Techniques, and Chapter 13, Berkowitz-Sherman Techniques. Note on the XYZ insurer data. All data will be included here. However, not all data is required for all methods. For example, claim count data is not used in the aggregate methods, but will be needed in the structural methods. Or, premium data is used in some aggregate methods, but not all. For instance, it's not used in the development technique. Background. These statements will be evaluated when reviewing structural reserve. The actuary is given the XYZ insurer data along with some additional comments, including claim department changes have occurred. New management says that current case outstanding amounts are much more adequate than in prior years. 2. Information services have changed. New systems have been implemented to speed up the claim reporting and settlement processes. And 3. Changes to the legal environment have occurred. For instance, tort reform, pricing restrictions, and mandated rate changes have led XYZ Insurer to reduce its auto portfolio over the past few years. Important data that we'll be using in the development techniques are as follows: reported claims, paid claims, reported claim counts, and closed claim counts. This data was obtained from Chapter 6 and can be referenced from Table 2, Table 3, Table 8, and Table 9 for the closed claim counts. This data is also used in Chapters 7 through 10 as well as 11 through 13. For the purposes of the development techniques discussed in this video, you'll notice that the data was cut off at 2003. Additional data that we'll ultimately be using are earned premiums and perhaps rate level changes. So we can see our earned premiums in column 1, our rate changes in column 2. If we're asked to compute the cumulative average rate level, we can do so as shown here in column 5, which is equal to column 4 minus 1, where column 4 is the cumulative average rate changes, which is the downward product of column 3, where column 3 is nothing more than 1 plus column 2. If we're asked to calculate the annual exposure change, we can do so using this formula here, which is column 1 divided by column 1 prior, all divided by column 3 minus 1. So for example, for accident year 2005, we can see that an exposure change of 21% is equal to 138,151 divided by 99,322 divided by 1.15 minus 1. Many of the recent questions on the CAS exam ask you to demonstrate your understanding of the techniques underlying a development approach. They also ask that you state whether the assumptions that underlie that approach hold given the particulars described in the question. To that end, we read you the following excerpt from the Friedland text. The underlying premise of the development method is that future claims activity can be projected based on historical claims experience. A primary assumption of the reported claim method is that there have been no significant changes in the adequacy of case outstanding over the experience period, and a primary assumption of the paid claim development method is that there have been no significant changes in the rate of settlement over the experience period. These methods also assume that the type of claim has not changed during the period and that claim reporting lags have not changed. Based on discussions with the company, many of these assumptions do not hold, so using the development method on the data given may not be appropriate. The development technique is illustrated in 3 sections below. Section A1, compile your data by year and development age. Section A2, select your age-to-age factors and your tail factor to calculate ultimate claim development factors. And A3, project estimates of ultimate claims and/or unpaid claims and/or IBNR. And so, to use the development technique, you'll need to compile data by year and development age as shown here, or as in most examples, the development triangle will be given to you. 2. Select age-to-age factors and a tail factor to calculate ultimate claim development factors. In this example, Friedland selects the age-to-age factors using a 2-year volume-weighted average. She presents a number of other averages though, simple, geometric, and medial, and we'll see a sample question on how to compute these types of age-to-age factors. Also, the full XYZ insurer example in the text includes more years. Here, we cut the data off to make it more manageable. Below, we will use a CDF to ultimate of 1.0135 at 72 months as our tail factor. So, to compute the 12 to 24 month age-to-age factor, we reference the values in the table above and see that 31,732 plus 46,783 divided by 19,477 plus 27,066 is equal to our 12 to 24 month factor of 1.687. We do the same for age-to-age factors from 24 to 36 months, 36 to 48 months, and 48 to 60 months, and 60 to 72 months. In order to compute our 12 to ultimate factor of 2.551, it is nothing more than the product of the age-to-age factors times our CDF to ultimate of 1.0135 at 72 months. In step 3, we project estimates of ultimate claims, unpaid claims, and/or IBNR. We begin with the reported claim data at 12/31/08, which is the latest calendar year diagonal from the reported claim triangle. We multiply the reported CDFs to ultimate, which we just computed above, in order to determine estimated ultimate claims. We then can compute IBNR broadly as estimated ultimate claims, column 4, minus reported claims, column 2. Or we can use a shortcut, where IBNR is equal to reported claims, column 2, times the CDF to ultimate, column 3 minus 1. For example, for accident year 2008, as of 12/31/2008, IBNR is equal to 18,362 times 2.551 minus 1, which is equal to 28,898. Notes on shortcuts. Friedland states, wherever possible, we first present the projection of ultimate claims, and using the projection, we then calculate the estimate of unpaid claims for IBNR and the total unpaid claim estimate. We say, for exam purposes, shortcuts always come in handy. To find the unpaid claim estimate, we could either subtract paid claims from the estimated ultimate above, or add case outstanding, reported claims minus paid claims, to the IBNR estimates above. See the full Exhibit 2 in Chapter 7 for more details, including the application of the development method to paid claims.